QTCAD is a computer-aided design tool for a quantum semiconductor-based hardware. It is a finite element simulator used to predict the performance of solid-state spin qubit device. The following features of QTCAD are Poisson solver to find electric potential, band alignment in heterostructure, Schrödinger solver, multi-value effective mass theory solver, lever arm calculator, Schrödinger Poisson solver, many body solver, a value splitting calculation tool, time dependent simulation of quantum control, work at cryogenic temperature in spin qubits. In this section, you will learn about QTCAD workflow. Let's break down the different stages and components. First step is device specification. The first step in the workflow involves selecting the technology and defining the device specification. In this case, the technology being used is nanowire. This step involves to design an arbitrary 3D geometry of the device, meaning you can configure the shape, dimension, and material used in the transistor. This step is crucial because it defines the foundation of the entire simulation. The accuracy of the result will depend on how well the device symmetry is specified. Second step is mesh definition with GMS. The second step in the creation of the mesh, which is representation of the device symmetry in small elements. A mesh is essential. You create the device into smaller, manageable sections. This is important because the Poisson solver and other numerical work these small sections to calculate electrical properties like potential and charge distribution. This process is known as meshing and finer mesh more accurate result, especially in area where the electric potential changes rapidly. However, finer meshes also require more computational power. And the third step is QTCAD. The third step is running the QTCAD software. QTCAD also comes with inbuilt quantum models and material, which means it's already include the physical property and the behavior of certain material and quantum effect relevant to the nanowire. This step run the heavy lifting computation and the flexibility of the Python API allow user to fine-tune their simulation and adapt their various scenario. And the fourth step is visualization and analysis. The final step involves visualizing the result of the simulation for analysis. The result of the simulation can be visualized through like PyPlot, PyVista, or Parallax.